All right, our next section is dealing with law of exponents and evaluating exponential expressions. And to do that, you really need to remember PEMDAS, because exponents comes before your multiplication, division, adding, subtracting. So for example, for number 1, if I'm doing 2 to the third, remember that means 2 times itself 3 times. So 2 times 2 times 2 is 8. For number 2, notice there's parentheses. There's nothing inside I can do to the parentheses, but then I'm taking -4 and squaring it. And -4 squared means -4 times -4, which would be positive 16. When we have a fraction that we're squaring, it means you're squaring the top. 1 squared is 1, and also squaring the bottom. 4 squared is 16. Remember, 3 to the first, anything to do with the first power is itself, or this is really just saying 3 times itself 1 time, which is 3. 5 is where it gets a little tricky. For number 5, there's no parentheses here, so you have to strictly follow PEMDAS. There's no parentheses, so then I do exponents. So I am squaring 4 first, which is 16, and then I'm multiplying 16 times -1. So this is how you get -16. Again, I squared 4 first. It's really like this, where you're squaring the 4 and then multiplying the 16 by -1. So it is a big difference of where you put the parentheses between 2 and 5 here. If you put parentheses around if you really want to square -4, you have to put parentheses around -4. Otherwise, it's just going to square the 4 and multiply by -1. And then for 6, again, we have to follow PEMDAS. So I have to do exponents before multiplication. So I would have 4 times 9, and that would be 36. As we go to number 7 and evaluate this function, it says evaluate an x equals 3. So that means you're going to put a 3 in for x. Again, follow PEMDAS now. So exponents first. 3 times 3 times 3 is 27. And then that would give me 54. 2 times 27. As I go to number 8, I'm putting -3 in for x, so this is where I would do 9 divided by -3 squared. And notice I put the parentheses around the -3 because I'm putting -3 in for the whole x. And that would be 9 divided by 9, which is 1. All right, so now there's going to be some law of exponents, we call them. The first one is called the product property. So you might want to underline or highlight that. I got a highlighter here. Product property. Okay. All right, so before we find the shortcut, let's try and do some problems like this. So notice all these problems, they have the same base. So we call the low number a base and the high number an exponent. So they all have the same base, x and x, y and y, 4 and 4. And they're all the bases are being multiplied together. So if we look at number 2, for example, I'd have x times x, which is x squared is, times, and then x to the 5th is x times itself 5 times. And if you notice, how many x's do we have being multiplied together now? Well, 7, so that'd be x to the 7th. If I did number 3, again, the same base of y, so y to the 3rd is y times y times y, and then I'm multiplying that by y to the 1st, or another y. And that gives me y times itself 4 times, or y to the 4th. So we don't want to be writing these out all the time, because if we had an exponent of like 50, we'd have to write 50 x's out. That wouldn't be fun. So look at the shortcut. I had exponents of 2 and 5, and I got an exponent of 7. I had an exponent of 3 and 1, and I got an exponent of 4. So the shortcut is if you're multiplying like bases, you keep one of the bases and add the exponents. 2 plus 5 is 7, 3 plus 1 is 4. So here's what we're going to write down for our first product rule of exponents. We're going to say x to the a times x to the b equals x to the a plus b power. All right, so that is your first law of exponent. And so now that we know that, we can use the shortcut for these. This one would be 4 to the 7th. Number 4 would be y to the 12th. 5 would be -5 to the 15th power. And last but not least, 6 would be x to the 14th. So that's the product rule. The power rule is our next one. I'll call that law of exponent number 2. And I'm going to simplify this a little first before we get going. Let's just say I had x to the third squared. X to the third squared is really x to the third times itself, x to the third, which now it looks like up here, x to the 6th. So instead of writing that out, that middle step, how can I get 6 from 3 and 2? Right, we just multiply them together. So here's the shortcut for that one. If you have x to the a, all raised to the b power. So notice we only have one base here. Up top here we had 2 bases that were multiplied together. Here we only have one base, but 2 exponents. That is the same as x to the a times b power. So that's your shortcut. So for number 1, that would be the same as 5. You keep your base the same. Multiply my exponents. 5 to the 18th. Number 2, keep the y the same. Multiply your exponents. Y to the 16th. And number 3, again, my base is x. Multiply my exponents, 35. That's law of exponent number 2. Next one is a power of a product. And now the only difference here is that we have multiple products or multiple factors inside the parentheses. So that doesn't really change anything. All that matters is that, let's just say I have, as my example, 2x to the third. Again, x to the third means that, or 2x to the third means I'd have that 3 times itself 3 times. And now I can really just multiply 2 times 2 times 2, which is 8, and x times x times x, which is x to the third. So all that means is the shortcut is I could have done 2 to the third times x to the third. All right, so here is your rule. Let's call this the third one. If I have ax all raised to the y power, that is the same as a to the y times x to the y. And then also it says a power of a quotient. That's another law. And that is where we're just going to take each to an exponent. So let's say I had a over b raised to the x power. That would be the same as a to the x over b to the x. So when you have a fraction, you just take the exponent to each part of the fraction. When you have multiple factors, you take the exponent to the multiple factors. So for example here, this would be s to the 4th, t to the 4th. Because remember, these are really ones. There's really a 1 on each of those exponents. So 4 times 1, 4 times 1. Same with this. I have an exponent 1 on the 2, exponent 1 on the a. So this would be 2 to the 3rd, a to the 3rd. And I can make that 8, a to the 3rd. For number 5, again, there's a 1 on the exponent. So now we really start multiplying to all the exponents, and there's a 1 on the z. So this would be negative 5 squared, x to the 4th, y to the 6th, z to the 2nd. And then we want to simplify that negative 5 squared. So 25, x to the 4th, y to the 6th, z to the 2nd. The negative, again, the negative x has an exponent of 1 here, so this would be negative x to the 5th, y to the 15th. Number 5, m. Now we're using this one where we're taking the exponent to the top and the bottom. So we have m to the 7th over n to the 7th. And 6, y to the 3rd over 7 to the 3rd. And you can figure out what 7 to the 3rd is. That's 343. All right, moving right along. We have 2 more that we're going to go over in this one. Next one, the quotient rule for exponents. All right, so let's just say there's a great example to go over it. Actually, x to the 5th. So x to the 5th is x times itself 5 times. X squared is x times itself 2 times. And if you have factors separated by multiplication, same on top as the bottom, you can cancel. So I can cancel this x with this x with this x, and I'd be left with x to the 3rd power. Now, what's the shortcut? Well, 5, 2, and 3. 5 minus 2 equals 3. So here is your ultimate shortcut. If you have x to the a divided by x to the b, you keep that base the same. Notice how the base was the same, but I subtracted my exponents now. A minus b power. So my base is the same. I'm dividing, so therefore my base stays the same, negative 4, and I subtract my exponent, negative 4 to the 5th. If there's multiple factors, then you're just going to think of it as separate ones. So this is really like 2 over 1 times x to the 5th over x to the 1st times y to the 2nd over y. And now I think of it as 3 separate problems now, really. 2 divided by 1 is 2. X to the 5th over x is x to the 4th. 5 minus 1 is 4. And y squared divided by y is just y. Because again, I subtract my exponents there. All right, and the last one is the 0. The last one for this video is the 0 exponent rule. And anything raised to the 0 power, what could that be? So if you're not sure, let's do, if I said x to the 3rd divided by x to the 3rd, right? Well, x to the 3rd divided by x to the 3rd, using the law of exponent right up here, we subtract, we get x to the 0. So what does x to the 0 equal? Well, if I actually wrote out x to the 3rd, it'd be x times itself 3 times on the top, 3 times on the bottom. And notice, all the x's are ultimately going to cancel out. And when things cancel, what do they equal? 1. So therefore, x to the 0 must equal 1. So here is the rule. Any base raised to the 0 power equals 1. So 3 to the 0, guess what 3 to the 0 is? 1. Guess what this whole thing, the whole thing's raised to the 0 power, guess what it's equal to? 1. Guess what negative 4 to the 0 is? 1. Negative 4 to the 0. This is where it's a little tricky, because remember, you're raising 4 to the 0 power. 4 to the 0 is 1, right? But then you have that negative in front, so this one would be negative 1. 5. Remember, there's times between the 5 and the x. So the x to the 0 becomes 1, but you still have that 5 in front. So we're doing 5 times 1, which is 5. And now I'm doing negative x to the 0. Again, very similar to number 4 here. X to the 0 is 1, but I have the negative in front, so negative 1. All right, that's some of the law of exponents. Most of them. We have a couple more to go over tomorrow or next video.